Good evening everyone. So welcome back to NEET World. So today in this session we will be discussing our continuation to the last class, that we are discussing about pH calculations right now. So how do we calculate pH of acids? Now, like strong acids, if they are given, if concentration of H plus ion is given, so simply we can use minus log of concentration of H plus ion expressed in normalities right now. So now based on that we have seen few models in the last class, okay, we will be continuing to that discussion. So what about the self-ionization of water? What are the ions formed? H plus and OH minus. So ionic product of water at 25 degrees Celsius is found to be 10 power minus 14 is the ionic product, but concentration of H plus and OH minus ion is found to be so when water undergoing dissociation or ionization here, so we will get one H plus and one OH minus ion. The concentration of H plus the concentration of H plus and concentration of OH minus ions are same here, and number of H plus and number of OH minus ions are also same. Therefore resultant solution will be neutral, 10 power minus 7 molar concentration. This is at 25 degrees Celsius. This is what we have discussed. So now if I apply pH to this, pH will be equals to minus log concentration of H plus ion we are taking in normalities. So for water, if you place this here, it will be pH will be 7. We are saying it as neutral right now. Then next, yesterday I have given few questions. Just tell me for few more questions. If concentration of H plus ion is 10 power minus 5 molar, then pH, what is the pH? 5. Simply 5 you can answer. So how you got this 5? So just use minus log of H plus ion, then concentration of H plus ion is 10 power minus 5, so that will be minus 5 here we can write, so minus into minus 5 plus 5 log 10 1, pH is 5, okay. And the next, here I have given you one generalized one to remember. So if concentration of H plus ion is something like 10 power minus x, then pH is x, like this we have studied yesterday only, okay. If concentration of H plus ion is in this format, concentration of H plus ion is normalities are x into 10 power minus 5, then what I told you for pH? pH x into 10 power minus 5 form, y minus log x. So for example, concentration of R, like this they have mentioned 0.02 molar, 0.01 molar sulfuric acid is given, solution is given, then pH is how much for this? 1.98. So how do we did this? So pH will be taken as minus log concentration of H plus ion concentration is how much here?
10 to the power minus 2.
So you should take it is in molarity, but we need it in normalities.
Okay,
so 0.01 into its 2. Number of H plus ions released are 2. So 2 you take. So therefore, so you can write 2 into 10 power minus 2. Okay, this will be the normality now. Okay, so the next, so here it is in this format right now. So just what to do? Y, what is y here? 2 minus log 2. So 2 minus 0.3, 1.7 will be the pH of that particular solution. Is this clear or not? Yeah. So the next one is, if I give concentration of, or what is the pH of 10 power minus 8 molar HCl. Tell me what is the pH of 10 power minus 8 molar HCl? So simply you are saying it as 8, but 8 is not possible now. Since HCl is an acid, pH must less than 7, because below 7 we have acidic region. Since HCl is an acid, its pH must be less than 7. So what to do now?
14 minus 3.
Yeah, so look at here, no, not like that. See, concentration of H plus ion, like H plus ion coming from this will be H plus Cl minus, right now. So now look, I am taking pH of 10 power minus 8 molar HCl solution means this solution must contain HCl as well as water also, right now. So now water also dissociate, it's a weak electrolyte, it dissociate to give H plus and OH minus. Now what I am asking pH. pH means minus log concentration of H plus ion. So what, like H plus ions are now coming from both from acid as well as from water. So you need to take total H plus ion concentration here. When pH is given less than 10 power minus 6 for acid, then consider, when concentration of H plus ion is given less than 10 power minus 6, then consider H plus ion concentration from acid, H plus ion coming from acid as well as coming from water. It means what is the total H plus ion concentration here? See, pH means minus log concentration of H plus ion we are saying now. So this H plus ion is coming from water as well as acid. You take total H plus ion coming from both of these things. It means minus log concentration of H plus means what I should write? H plus ion from acid as well as H plus ion from water.
How much H plus is releasing from water?
Water at 25 degrees Celsius, what is the concentration of?
Minus 7.
10 power minus 7, 10 power minus 7. So that value is fixed now. So take here H plus ion coming from water, concentration is how much? 10 power minus 7, and H plus ion from acid is how much? 10 power minus 8. See, this value is smaller than H plus ion from water, therefore you should not ignore this. If concentration of H plus ion is greater than 10 power minus 6, then you can ignore H plus ion coming from water. If it is less than or equals to 10 power minus 6, don't ignore it, take it into the calculation. Now tell me what is your answer here? So minus log, what you can take here?
15.
1.1 into 10 power minus 7, can I write? Yes, we can write. 0.8 into, so 10 power minus 8 means 10 power minus 1 into 10 power minus 7 I can write now. Here 1 we have, so this 1 plus 0.1, that is 1.1 into 10 power minus 7. Okay, so then next, so what is pH here? 7 minus log 1.1. Okay, so look at here, we have 10 power minus 8 plus 10 power minus 7. This one I am writing it as 0.1 into 10 power minus 7 plus 10 power minus 7. Can I write it like this? So here 1 into 10 power minus 7 is nothing but 1 plus 0.1 means 1.1 into 10 power minus 7. So that is what I have taken here. Is that clear or not? Right. So now this will be, yeah, so this will be how much? Around this log 1.1 value is around 0.04 like that. So we will get around, this is 6.96. So less than 7 now, less than 7 means now it is acidic. Okay, whenever concentration of H plus ion is given less than 10 power minus 6, what you should take? Take concentration of H plus ion from water and acid. Overall sum, therefore definitely your answer will be less than 7 in that case, then it is correct. Okay,
They give 7.
that is also, it is also less than, it is also less than or less than 10 power minus 6 now. So you should take from water also. Now itself you do that. Concentration of pH of 10 power minus 7 molar HCl solution is how much? Tell me. So Adya Yadav, your answer is incorrect ma here. That is what I am explaining here. So you have to take concentration of H plus ion both from acid as well as from water. Whenever its concentration is mentioned less than, if the concentration is mentioned less than 10 power minus 6, you should take concentration of H plus ion coming from acid as well as from water. Okay? Like that you will be getting.
So we should take 1 into 10 to the power minus 7 there.
1 into 10 power minus 7. Okay? Like what is the total H plus ion concentration now here in the pH formula? 10 power minus 7 plus 10 power minus 7. That's it. Okay? So 2 into 10 power minus 7. So your answer will be minus 7 minus log 2. Okay? Log.
0.3.
So it means that's it. Is that clear or not? Right. Okay. Then next. Right. Calculate pH of 10 power minus 3 molar NaOH. pH of 10 power minus 3 molar NaOH.
Yesterday we did this. 10 power minus 2 we did.
Tell me fast. So what to do? So given base now, so here you should find, you will get concentration of OH minus ion. Whatever the value is given, that is for OH minus ion. So POH you will get, that is 3 here, POH. Then pH plus POH 14. So pH will be 14 minus 3, that is 11. Okay, this is simple one. Okay, and the next one is, see, just remember this, if concentration of H plus ion, see, initially, see, for example, if for an acid, if concentration of H plus ion is increasing, what happens to the pH value? Decreases, right now. So now, here I am giving a question for you, just tell me what is your approach. See, initially pH is equals to 5. Then pH, by increasing the concentration of H plus ion, pH value decreases. So pH become 2 here. Initially 5, later it become 2 by increasing the concentration of H plus. So now what is the increase in the concentration of H plus? What is the increase in the concentration of H plus? So how do you answer this kind of questions? So look at here. If concentration of H plus ion is increased by x times, then pH decreases by x units. What I am saying, if concentration of H plus ion increased by x times, then pH decreases by x units. Okay, so for example, here pH 5 becoming pH 2. So how many units it is decreased? 3 units, right now. Then concentration of H plus ion will increases now. How many times it increases?
X times, 3 times.
So it means you can write it as increase it by
Negative
x na. So it will become like 10 power x times. So you can 10 power x. So it means 10 power 3 it will be. It means 1000 times it will be increases. Okay, like this. For example, one more question I will give you, and one more thing here, you will get one more model question here. When I have HCl of concentration N1 and HCl with concentration N2 and volume V1, volume V2. So now this solution have respect to pH, right now. This solution also have its own individual pH. right now. So when we mix these two, we'll get a resultant solution. So what is the pH of this resultant solution? So first of all, you need to find H plus ion concentration, resultant H plus ion concentration. So by using that N1V1 formula, N1V1 plus N2V2 by V total, V1 plus V2. This gives concentration of H plus ion for resultant, this resultant solution. You got H plus ion resultant concentration, so you can put it here. So pH will be minus log concentration of H plus ion for this resultant. That will give you the resultant pH. Okay, is this clear? Right. And what are the other model questions we have? Next, write one more question. Not question, we'll see one more model here, like pH, calculation of pH of weak acids. So in case of weak acid, give an example. So this will dissociates to give O minus plus H plus. Initially, the concentration of weak acid is C, I am saying, at time T0. Here we will be taking 0, 0. After some time T at equilibrium, this will be C minus C alpha, this will be C alpha, this also. Now what is the formula of pH?
Hydrogen
Minus log concentration of H plus. So what is the concentration of H plus ion we got? C alpha, right now. So now if you have direct, see, concentration like this, in the exam they will give like this question. What is the pH of 0.1 molar acetic acid? It means 0.1 molar means you got concentration is given. What about alpha value? That alpha won't be given. But yesterday we have studied Ostwald's dilution principle. What is that? Alpha equals to root over Ka by C we got, concentration we got. Okay, so it means here I can write in the place of alpha, I can write this value right now. Try to simplify that. Concentration of H plus ion now becomes
under root
C into root over Ka by C we got. Okay, now you can write under root C square by C I can write. I can remove this, so that we will get root over Ka into C. This will be the concentration of H plus. Yes. So in the exam they will mention Ka or pK of that particular acid. Okay. So they will mention what? Ka or pK value. So you can put here directly to get the H plus ion concentration, or you substitute over here. What you will be getting here? Minus log concentration of H plus ion means root over Ka into C. Okay, then so look at here. So this I can write, root means 1 by 2 I can write. So here 1 by 2 minus log of Ka, plus minus log C. Like this I can write. See, 1 by 2 minus log Ka means pKa. Here it is as it is, minus log C. So this will be the final formula. So what is the final formula of weak acid? pH equals to half into pKa minus log C. I don't know whether you remember this or not, just remember this final formula. Okay, right.
We can also write log K or directly pKa.
Minus log Ka or directly pKa you can write. Okay, so now in the exam they will give pH of 0.1 molar acetic acid solution having pKa of acetic acid as 4.74. Then tell me what is the pH? How do you do this? pH will be equals to half into pKa given now 4.74 minus log C. Minus log C. C is how much? 0.1 log 10 power minus 1. Okay, so this will be
Normality convert.
for this n factor is 1 only, no? So molarity normality here equal.
1. So 3.7.
So this will be minus 1 becomes plus 1 here. 5.74 by 2. So this is 2 za. Next
0.8 za.
8 za.
2.87.
7 za. So this will be the pH of the particular solution. Is this clear or not? Right. Okay, 1 minute. Okay, next important one is salt hydrolysis. What we are discussing? Salt hydrolysis. What is this salt hydrolysis means? For example, we can make the salts by combination of different acids and bases. So we have like salts are formed from acid base reactions right now. So now acids are strong acid we have,
Weak acid.
as well as weak acid we have, and strong base we have, weak base we have. Now we have 4 different substances. By combining every time 2 we will get, see, salt can be formed when I mix strong acid and a strong base. Now salt of strong acid plus strong base we have. Next salt formed from salt of strong acid and a weak base we can have, and salt of weak acid and a strong base we have. Next salt of weak acid plus a weak base. These are the 4 combinations possible right now. Okay, so give example for each of these. I am taking strong acid HCl, strong base NaOH, weak acid I am taking acetic acid, and weak base I am taking ammonium hydroxide. Okay, so now mix them and tell me what are the things we will get here. Tell me, first one, salt of strong acid, strong base. So when HCl NaOH react, we will get NaCl. Right now? Next, here you tell me, salt formed from strong acid and a weak base. Strong acid, HCl, weak base. So we will get NH4OH plus HCl gives NH4Cl. Okay, this is an example. Next, weak acid plus strong base. Weak acid, acetic acid plus NaOH, sodium acetate, CH3COO Na. And this example here, mix these 2 things, sodium acetate, like ammonium acetate, anion from here, cation from here, CH3COO minus NH4 plus, like this we will get right now. Okay, so now hydrolysis of these compounds give what type of solution? See, these salts are formed from either combination of acids and bases only. Now if I hydrolyze these salts, what will be the respective solution, whether it is acidic or basic? That is what the question here. So when we have first combination is what? Salt of strong acid plus strong base. So this salt, if we hydrolyze, first of all it won't undergo hydrolysis. Okay, if we assume it is undergoing hydrolysis also, what will be the products formed? From Na plus OH minus from here, NaOH strong base, Cl minus H plus, HCl strong acid. Overall it is a neutralized one. So pH will be 7, neutral. So here for strong acid strong base combination, they won't undergo hydrolysis. pH for that mixture of solution will be, that hydrolysis solution will be 7. Next, combination of salt of
Weak base and strong acid.
weak acid, strong acid and a weak base, and third one we have weak acid and strong base. Out of these combinations, I am taking this particular example for clear cut discussion. So what I am taking here, I am taking hydrolysis of salt of formed from weak acid and a strong base. Okay, this will be formed by the combination of weak acid plus a strong base like NaOH. Now if I hydrolyze this, what happens, tell me? So from here, what is a cation? Acetate ion is a cation, and from here anion is, sorry, what is a cation here? Na plus, anion is acetate ion. From this H plus OH minus. Therefore, cation from here, anion from here will combine like that. So acetate ion and H plus, so it will form acetic acid, CH3COOH plus NaOH. See here, this is a strong electrolyte. NaOH is also strong base, means strong electrolyte. So we have Na plus. So these spectator ions like Na plus is removed. So now what part of this salt are involving in the hydrolysis process? Only anionic part now. So you should say this is an example of which salt hydrolysis? Anionic salt hydrolysis. What is this? It is a anionic salt hydrolysis. Is this clear or not? Now in case of the second one, that will become cationic salt hydrolysis, because HCl will be cancelled out both sides, because HCl formed here strong electrolyte in this case, HCl, Cl minus Cl minus cancelled out. So what is the part involving? Ammonium ion only. So cationic hydrolysis this is. Okay, are you getting how to identify cationic and anionic hydrolysis? Right. Okay, after this what we are doing here? Hydrolysis process. So at time t0 we have concentration of the salt C, let us say, and after some time t equilibrium, what happens? Some amount of this salt converting into respective compounds. It means C minus, C alpha in case of dissociation. It's not dissociation, it is what? Hydrolysis. I am taking H. H represents degree of hydrolysis. Okay, their degree of dissociation, here it is degree of so what is the concentration of this compound now? CH. Right. Now see, after this salt undergoing hydrolysis, what is the ion formed here? So OH minus ion is forming along with this weak base. So OH minus is forming means resultant solution will be basic. So the salt hydrolysis of weak acid plus strong base will be gives a basic solution. It means pH will be definitely
higher than 7.
So 7 plus something we will get now.
Yes.
So what is that something we need to know now? We will do that now. Okay. So now if I want here directly I can say OH minus ion concentration is how much? CH. Again concentration of that particular salt will be mentioned in the question, but what we require now? What is the value of this H? It means we need to find this H. That if they directly gives the question in the question, you can put it here and you can do. But sometimes they won't give this directly, they will give some indirect ways. Okay, we need to know that. Right. Look at here. Okay, so now if I want to write acetic acid, this acetic acid I am taking. So how it will dissociate?
CH3COO plus H plus.
CH3COO minus plus H plus. Right now? So now for this acid, it is undergoing acid dissociation now. So we are writing acid dissociation constant as Ka. That is nothing but acetate ion concentration, H plus ion concentration by acetic acid. Similarly, this compound is undergoing salt hydrolysis. So what I should write here? Hydrolysis constant Kh. That will be taken as acetic acid concentration. Next, OH minus ion concentration by CH3COO minus ion concentration. That's it now. Right. So now if we want to substitute these values, what you will get here? KH, CH into CH by C minus
H1 minus H.
H. So from this KH will be CH square by 1 minus H. Similarly here I am taking 1 minus H is very hydrolysis to very lesser extent, therefore it will be 1. So what will get KH will be now?
CH square.
KH will be equals to CH square. So from this H will be KH by C to the power 1 by 2. Like this we can write. Okay, similar to that Ostwald process only we got here hydrolysis constant also, like hydrolysis KH is hydrolysis constant, H represents degree of hydrolysis. Similar to that Ostwald's dilution principle we have now, alpha equals to root over
Alpha is directly proportional to
Ka by C we got.
V or
Like this we got. Up to here it is clear now. Now look at here, consider this is equation 1, this is equation 2. Observe 1 and 2, what you are seeing?
react.
Just take Ka into H, Ka into H you take, Ka into KH.
Cancel.
Acetic acid, acetic acid. Acetate ion, acetate ion. So what you are remaining with? H plus ion multiplied with OH minus. So these two are nothing but
pH, sorry, 10 to the power minus 1 at 25 degrees.
10 to the power minus 7 and this is also minus 7. That is,
Minus 14.
that is nothing but KW. So now KW will be equals to Ka
Into KH.
into KH. Okay. So why I am taking this? See here.
Equals to KW by
See here we got H. What we are struggling for? We are struggling for H. We got this H here also, and sometimes instead of KH they will be giving KW and Ka. So what will be having here? KW by
KA.
Ka.
From that it is
So you substitute here. H will be equals to root over KW by Ka into C. Here I have kept this. Okay. So now what we got? Here OH minus ion is equals to CH. Okay. Directly you can put here value, or see one more thing we have. This is OH minus. See if I want pH, what you will do? See
minus 4
H plus ion into OH minus ion
equals to KW.
equals to KW. So from this H plus ion concentration if I want, I can take KW by OH minus ion. Right now, so instead of writing these, I can use this. Now H plus ion is equals to KW by KW. What I can write? OH minus. OH minus is nothing but CH. CH, H means what here? KW by root over KW by Ka into C. Into C. Okay, this is what we can write. Or if you are getting confused with this thing, directly use whatever you have here. What you have here? OH minus ion is equals to C into what is H?
Under root
KW by Ka into C. So write it inside. What happens?
under root
C square KW by Ka into C. So I can remove this. So what we are having finally? See, I will give final equations how to remember also, no worries. Just, but this derivation is also important here.
or we can write under root KH into C.
Like this we have. This is what final equation we got. So now apply minus log on both sides.
POH 1 by 2
What we'll get here?
1 by 2 minus log
1 by 2
minus
minus log KW I am writing. Again
into
minus plus minus log C I am writing. Okay.
minus
And right minus of minus log
K
K. We can write it like this. So 1 by 2 minus log KW means PKW. Next this one minus
plus
pKa
plus pk
minus log C I am writing. So why plus pKa? Minus log Ka means
pk
pKa. Okay, so here I can simply write this pKw value is how much? Kw you are saying 10 power minus 14. So pKw is how much? That will be simply 14. So this is what?
poh
So POH will be
half into
half 14 by 2 means 7 minus 1 by 2 pKa plus log C. We can write it like this. Is this clear up to here? Now it is POH. If they ask for pH, pH is equals to 14 minus POH. So POH formula here you got. So what will be the final answer now? 14 minus 7. That will be 7 minus into minus plus. So 7 plus half into pKa plus log C. I will tell you now what is the best way to remember all these formulas. See, what is this salt we studied till now?
weak acid weak
We have studied this about salt of weak acid plus strong base. See, what is this strong base now? Resultant salt solution also basic. It means pH will be definitely above 7. So 7 plus something will be there. 7 plus half into, see, above 7 we are saying. So what is the weak one here it is involved?
below 7
Weak
Near
acid.
7.
Weak acid is involved. Na? So weak acid has Ka. So you should take here pKa plus log C. Okay, C means here molarity. What we are taking it is molarity of that salt. For example, I am taking salt of strong acid plus weak base. You tell me what?
7 minus half
7 minus half.
K
So here, in case of weak acid involvement, we have taken here K. Here weak base is involving, so we should take Kb. So half in minus 1 by 2, 7 minus 1 by 2 pKb plus log C. That's it. So now one more combination we have. What is that final combination? Salt of weak acid plus weak base.
neutral
How you are saying neutral? It depends upon what type of weak acid and what type of weak base is involved here. Okay, so now pH formula will be taken as, it is also having 7. Next plus here half into, when we have weak acid we have pKa in the formula. When we have weak base we have pKb. Now we have both weak acid and weak base. So
then how can it be
so it should be pKa and pKb should be involved in the formula right now. So 7 plus half into pKa minus pKb.
log C
Here the salt, this salt is independent of concentration. The pH of this salt is independent of concentration of that salt. What I am saying?
pH is independent
pH is independent of concentration in case of weak acid and a weak base combination. Salt formed from weak acid weak base combination.
then y plus not y
So here this plus this indicates, it means whether solution is acidic or basic depends upon their pKa pKb values. We know for a acid if the acid is more acidic, its Ka value will be greater Ka value. So if Ka is more, its pKa will be less. Okay, so for a better acid, Ka value will be greater, pK will be lower. So if pK is lower, now what happens? This will be negative value. So 7 minus something it will be becoming. So do you got what I am saying here? It depending upon what now? pK and pKb values. Okay, that's it. So you need to remember these three formulas. Okay, right. So what are the three formulas? Just tell me in a quick way.
Half
For a salt hydrolysis of weak acid plus strong base.
weak acid plus strong base.
Weak acid, strong base.
Basic solution.
Salt will be, resultant solution will be basic.
pOH equals to
Come with pH. Okay, pH equals to
7 plus
half
pKa
pKa
minus G plus log
plus log C. That's it. Okay. So I hope you got the concept here what we discussed right now. So now let's do one or two questions based on this.
Sir, minus plus
pH equals to 7 plus
second one. pKa
plus log C plus log C. Okay. Now write the question. pH of a 1 molar pH question will be like this. pH of a 1 molar sodium acetate solution will be dash given pKa equals to 4.74. Tell me fast. Very easy.
Log 1 is 0. Log 1 is 0.
0. So pH, see what type of salt they are given? Weak acid, strong base salt. This salt is formed by weak acid, strong base.
9.37.
So upon hydrolysis gives OH minus ion, basic resultant. Okay, so pH will be 7 plus half into pKa plus log C. Then next 7 plus half into 4.74 plus log C. What is C here? Log 1. It is 0. So 7 plus 1 by 2, 4.74. It means how much it is?
2.37.
2.37. So pH will be 9.37. So resultant solution is basic only now. Like this. Next. Write one more question. Calculate pH of ammonium acetate solution given pKa of acetic acid and pKb of ammonium hydroxide pKa of acetic acid 4.76, 4.75. What is the pH of this resultant ammonium acetate solution upon hydrolysis? Simple. When this weak acid and a weak base is combined, we will get a salt of
7 plus
weak acid plus strong base, weak acid plus weak base. Right now, so for this mixture, what is the formula I told you? Weak acid plus weak base salt hydrolysis. 7 plus half into pKa minus pKb. Right now, so pH will be now 7 plus half pKa 4.74 76 minus 4.75.
0.01.
So pH will be
3.51.
7 plus 1 by 2 0.01. So you can simplify this, you will get around 7 only, 7.005. 7 plus 7.005. Okay, right. So one more homework question. You do this later on. Just write the question. Calculate pH of 0.1 molar ammonium chloride solution given Kb of ammonia as 1.8 into 10 power minus 5. 1.8 into 10 power minus 5. That's it. So how to do? I will tell you, just I will give you the clarity of the concept. Tell me.
7 minus half pKb.
pKb plus log C.
Log
C.
But here they give kb, so we should convert
Into pKb
minus log,
of Kb.
so which is 1.8.
5 minus 1.8.
Minus 1.8, which is 4.2.
That is also not 4.2, that is 4.74 only. That is also
Which is
pKb value for here.
okay, 1.8 logs. Log
Yeah.
1.8 is 0.7. Sorry, 0.3.
Okay, and the next concept here. So is there any confusions here? Everything is clear now?
In exam, will they give the value of log 1.8 or?
Like that they will give nearest values at least, or you need to know. Here log 2 value you know now?
0.3.
Just relate it to that.
4.7. 7 minus half into 4.7.
Next thing is
5.765 answer.
your answer will be around 5.12.
5 here. 4.7.
Okay, we have something called amphiprotic ions. So what is this amphiprotic ions? See, I have bicarbonate ion here. What we have? Bicarbonate ion. So this bicarbonate ion can now release a H plus ion, this H plus ion, and can act as a acid like this, right now. Or this bicarbonate ion can accept a proton and become a carbonic acid also.
H2CO3.
Now it has, this ion has both natures now. Either it can show acidic nature by releasing H plus ion, or it can accept a proton and show its basic nature.
Basic character.
So it has both.
It's just like amphoteric.
No, but it should be called as amphiprotic. So now pH of this amphiprotic acid, they will ask pH of this amphiprotic ion. So how do you calculate? See, for example, I am taking H2CO3 only. Now if it is released H plus ion, we are writing HCO3 minus. How many H plus ions are released? 1. Out of 2, 1 acidic hydrogen is came out. So we should call it as first dissociation, Ka1. Respect to logarithm value will be pKa1. Now if it is releasing one more,
pKa2.
CO3 minus 2. So here it should be called as pKa2. Now I am asking pH of this middle one now. This amphiprotic means this one, not this, not this. So pH of this, if they ask what to take, it should be pK average of these two things, pKa1 plus pKa2 by 2. That's it. Is this clear? Okay. So now one more thing. Sir, in the exam, what if they ask pH of this component?
pKa1.
See, what type of acid it is first of all? Carbonic acid is a weak acid. Therefore, you should find using pH of a weak acid formula. What is pH of a weak acid formula? Just now you have studied that.
This one.
Before salt hydrolysis.
Consider water also. Like
After that, just check.
half pK minus.
Ha. So this is a weak acid now. So now pH formula should be taken this one. pH equals to half into pKa minus log C. So log C means what? Concentration of this particular acid. I have given one question also, just check below that.
Yes, pH of one more.
pH of,
One more CH3CO in it.
not that one. One more.
Calculate the pH of.
Okay. So if they ask for what is the pH of this component, you should use weak acid formula. Why? Because this is a
Weak acid.
weak acid. What about this? If they ask for this ion, what is the pH formula I should use?
Base.
So this compound is nothing but a salt hydrolysis one. For example, I am taking carbonic acid, I am treating with NaOH, 2 moles of NaOH. Now tell me what is the resultant component formed? It's a strong base, 2 moles are there. So abstract these 2 protons so that we will get Na2CO3. Na2CO3 is nothing but a salt. Okay, so if this salt is there, so this is carbonate ion is nothing but a salt only here, I mean from this. So if I do hydrolysis of this salt, what happens?
Is it a basic salt?
So it will give us carbonic acid plus
Strong base.
NaOH. So it means resultant solution is basic. So it means for this carbonate ion, if they ask, you should use formula of pH formula of
Basic.
base weak acid plus strong base combination salt hydrolysis formula. That is nothing but 7 plus half into pKa
Plus log C.
plus log C. That's it. Okay, this is clear or not? Right. Okay, and you might be getting a doubt that, sir, which pKa value I should use here? We have 2 pKa values. So this ion is there na, so it's before one pKa. So you should use here pKa2. That is also clear. Now I am giving one ion. Now polyprotic acid I am giving. You just tell me what are the different pH formulas I can use. H3PO4 I am giving you. So H3PO4 pH value, how can you find? Now if I remove one proton from here, it becomes H2PO4 minus. So what is the pH you will use for this component? You write here beside this. So you make your concept clear with this kind of approach. Okay, and now one more proton I am removing, it becomes HPO4 2 minus. So tell me what is the pH of this component right here, and one more proton if we remove, it becomes PO4 minus 3. So what is the pH of this component, you tell me, like this.
Is second one amphipotic and third one also?
Also amphiprotic. So but here it is involving pKa1, here it is pKa2, it is pKa3. That's it, simple. These two are now what? Amphiprotic. It means simple pH formula, pKa1 plus pKa2 by 2 for this ion. For this pKa2 by pKa3,
pKa2 plus pKa3 by 2.
2. That's pKa2 plus pKa3 by 2. For first one,
weak acid, half pKa.
It is a weak acid, so half pKa
minus log C.
So C is molarity, I am saying again and again. Okay, pH here, this one half pKa1 plus pKa2. For this,
Average, right, sir?
okay, pH for this 2 pKa, 2 are involving now, 2 and 3 pKa2 plus pKa3 by 2. For this, tell me here what is a ion involving anion? Only anion is there, no acidic proton is there. So phosphate anion salt hydrolysis. What is the pH formula in that case?
Acidic.
Tell me. See, we have this one. Now tell me, if it is undergoing salt hydrolysis, so what happens here? See, it is having 3 negative charges. It means it will take 3 protons from here. What is the resultant? One more ion remaining.
OH minus.
So resultant solution will be basic. So use the pH of that salt hydrolysis. So it means 7 plus half
pKa
plus
log C.
log C. But which pKa we should take?
Before pKa.
3.
pKa3.
That's it. Is this clear? Now practice the questions related to this up to salt hydrolysis from the module. Any doubts if you have, you can ask me. Okay, that's it. Any confusions anywhere? Nothing?